Welcome to Al Jazari channel, where you will learn dynamics as a primary course for high school and first-year engineering students. The work presented here is based on Engineering Mechanics, Dynamics book written by Hibbler and published by Pearson. Starting with Chapter 12, Kinematics of Particles. Problem F12, 1. Initially, the car travels along a straight road with a speed of 35 meters per second. If the brakes are applied and the speed of the car is reduced to 10 meters per second in 15 seconds, determine the constant deceleration of the car. Here we have a car that travels at initial speed, vi, equal to 35 meters per second at ti equal to 0. Then slowed down to travel with a final speed, vf, equal to 10 meters per second at tf equal to 15 seconds. We know that acceleration equals the change in speed divided by the change of time, or delta v divided by delta t. This equals vf minus vi divided by tf minus ti equal 10 minus 35 divided by 15 minus 0 equals negative 1.67 meters per second square. The negative sign means deceleration. So, the constant deceleration of the car is 1.67 meters per second square. The second fundamental problem. A ball is thrown vertically upward with a speed of 15 meters per second. Determine the time of flight when it returns to its original position. Here the ball is thrown vertically upward against gravity with an initial speed, vi, of 15 meters per second. As the ball is moving upward against gravity, its speed will reduce until it comes to rest, or its speed becomes vf equals 0. Then it reverses its direction and moves downward. The upward movement and the downward one have the same distance and time. So, if we find the time of the upward movement and multiply it by 2, we will obtain the time of flight when the ball returns to its original position. Assuming that the upward direction is the positive direction. We know the acceleration, the initial and final speeds. The equation that relates time, speed, and acceleration is vf equals vi plus a multiplied by t. This equation is used only if a is constant. Substitute by the given values. 0 equals 15 minus 9.81 t. The negative sign is given to the acceleration because its direction is downward, opposite to the positive direction. Solving this for t results in t equals 1.53 seconds. The time of flight when the ball returns to its original position equals 2 multiplied by t equals 2 multiplied by 1.53 equals 3.06 seconds. The third problem. A particle travels along a straight line with a velocity of v equals 4t minus 3t square meters per second, where t is in seconds. Determine the position of the particle when t equals 4s. Known that s equals 0 when t equals 0. We know that v equals ds by dt. So, ds equals v dt. Consequently, to find the position we have to find the integration of both sides. Solving this integration, known that s equals 0 when t equals 0 results in s equal 2t squared minus t to the power 3. At t equals 4 seconds, s equals 2 times 4 to the power 2 minus 4 to the power 3 equals negative 32 meters. The negative sign means that the position at t equals 4 seconds is to the left of the original position by 32 meters. The fourth problem. A particle travels along a straight line with a speed v equals 0.5 t to the power 3 minus 8 t meter per second, where t is in seconds. Determine the acceleration of the particle when t equals 2 seconds. We know that the acceleration, a, equals dv by dt equal d 0.5 t to the power 3 minus 8 t by dt equals 1.5 t squared minus 8. Substitute by t equal 2. A equal 1.5 multiplied by 2 to the power 2 minus 8 equals negative 2 meters per second square. The negative sign means deceleration. In this video 4 kinematics of particle fundamental problems were solved. In the next video more problems will be solved. So, stay tuned and do not forget to subscribe to the channel and activate the alarm to be notified of the new videos. Thanks for watching. If you like this video, so press like and share it. See you again.